Good morning, everyone. My name is Bandana Kumari. I am Assistant Professor in Department of Information Technology, IIMT College of Engineering at Greater Noida. Today, I am going to deliver lecture on CPU scheduling. So, these are the outline of today's lecture. So, first, I will discuss about basic concept of CPU scheduling, scheduling criteria, scheduling algorithm optimization criteria, types of CPU scheduling. So, there are so many scheduling algorithm. I will explain about FCFS, SJF, RTA, SRTF, priority, and round robin. So these are the basic concept of CPU scheduling. Scheduling is a fundamental operating system functions. Multi-programming increase the CPU utilizations. The algorithm scheduler uses is called scheduling algorithm. Several processes are kept in a memory at one time. So CPU burst distribution is of main concern. So several processes kept in a ready queue and by using CPU scheduling algorithm, we can allocate CPU among the process. Now I am going to discuss about scheduling criteria. First, CPU utilization. Multi-programming increase the CPU utilization. Throughput, number of processes that complete their execution per unit of time. Turnaround time, amount of time to execute a particular process. Waiting time, that time that has been waiting in the ready queue. Response time, amount of time it takes from when a request was submitted until the first response is produced. So these are the scheduling algorithm optimization criteria: maximum CPU utilization, maximum throughput, minimum turnaround time, minimum waiting time, minimum response time. There are two ways of CPU scheduling in which CPU allocates among the process. In the case of primitive scheduling, we can preempt and we can release resources from the running process and allocate to the higher priority process. In the case of non-preemptive scheduling, new process will executes after the execution of running process. Scheduling algorithms, CPU scheduling algorithm is needed to efficiently allocate the available processing time of a CPU among multiple processes that are competing for the CPU resources. The CPU scheduling algorithm determines the order in which processes are executed and how much CPU time each process is allocated. allocated. So first algorithm of CPU scheduling is first come first serve. First come first serve considered to be the simplest of all operating system scheduling algorithms. First come first serve algorithm states that the process that requests the CPU first is allocated the CPU first and is implemented by using FIFO queue. FCFS supports non-preemptive and preemptive CPU scheduling algorithms. Now I am going to explain the working of FCFS CPU scheduling by the example where the snapshot taken by at a particular instant of time is shown in the figure. In this example, process along with their arrival time and burst time is shown. As we know that CPU will be allocated according to their process having smallest arrival time in FCFS. So here process P1 has a smallest arrival time, so CPU will be allocated to process P1 at time 0 millisecond. P1 has burst time of 4 millisecond, so control of CPU will be remains with P1 till 4 millisecond. Then CPU will be allocated to the process that comes next. So we can see that P2 has allocated CPU after the P1 and their burst time is 3 seconds. After execution of P2, CPU will be allocated to the P3 and after that P4 and P5, and all process uh, take CPU according to their burst times, and after completion the execution CPU will be deallocated from the process. So completion time, P1 will execute at 4 seconds, P2 will complete their execution at 7 seconds, P3 will execute it at 8 seconds, P4 their completion time is 10 seconds, and P4 their completion time at 50 seconds. And turnaround time is equal to completion time minus arrival time. So we can see that completion time of P1 is 4 seconds and arrival time 0 seconds. So turnaround time of P1 is 4 seconds, P2 is P2 is 6, P3 6 second, P4 is 7 second, and P5 is 11 second. And waiting time is equal to turnaround time minus burst time. So we can say that turnaround time of P1 is 4 second and burst time is 4 second. It means waiting time is 0 second. At P2, turnaround time is 6 second and burst time is 3 second. It means waiting time is 3 second. And for process P3, uh, that have turnaround time is 6 second and burst time is 1 second. It means waiting time is 5 second. And turnaround time of P4 is 7 and burst time 2. It means waiting time is 5 second. And P5 their waiting time is 11 minus 5. It means turnaround time is 11 and burst time is 5 seconds. It means 6 second is waiting to 6 nanosecond is a waiting time of P5. Average waiting time is equal to total waiting time by 5. It means 3.8 millisecond is average waiting time, and average turnaround time is 6.8 milliseconds. Now, second algorithm of the CPU scheduling is shortest job first scheduling algorithm. When the CPU is available, it is assigned to the process that has the smallest next CPU burst. If the next CPU burst of two processes are the same, FCFS scheduling is used to break the tie. SJF scheduling may be non-preemptive and preemptive. So we can see the example of SJF non-preemptive. It means process will execute, after that we can allocate the resources to the another process. So we can see that P1, P2, P3, P4, P5, these are the process along with their arrival time and burst time. This is the example of shortest job first algorithm, and we can see that in this figure process P1, P2, P3, P4, P5 along with their arrival time and burst time. So first of all we will make Gantt chart of this example. At 1 second we can say that only one process P1 arrived in a ready queue, and we will allocate CPU to the process P1, and P1 wants CPU for the 7 second, and after the completion of P1 we will allocate next process that have shortest job first. It means shortest burst time. So we can see that P3 wants only 1 second. It means CPU has taken CPU process P3 has taken CPU only 1 second. So we can allocate CPU to the P3, and after that we can see next process P4, they wants only 2 seconds for their executions. So we will allocate CPU to the process P4, and after the completion of the process P4, P4 will terminate it and deallocate the resource and allocate to the next process. So we can see that process P2 that have the smallest burst time in comparison to process P5, so we will allocate CPU to the process P2, and after the completion and after execution of the process P2, we will allocate CPU to the process P5, and P5 will take 8 seconds for their execution. So now we will make next uh, completion time, turnaround time, waiting time. Completion time, it means when process will complete. Uh, at 8 second, process P1 will completed. At 16 second, process P1 will complete their execution. At 9 second, process P3 will complete their execution. At 11 second, process P4, and at 24 second, process P5 will execute their completion. Turnaround time, it means completion time minus around time. We will calculate, and waiting time, turnaround time minus burst time. So we will calculate average waiting time and turnaround time. So average waiting time is 6 millisecond and average turnaround time is 10.6 millisecond. Shortest job first primitive, it means shortest remaining time first. In primitive shortest job first scheduling, jobs are put into ready queue as they arrive. But as a process with short burst time arrives, the existing process is primitive and the control of CPU will be assigned to the process having a smaller burst time. So these are the this is the example of shortest remaining first scheduling. In this example, process P1, P2, P3, P4, P5, P6 along with their arrival time and first time. So we will make first of all Gantt chart. So at 0 second we can see that process P1 arrived at ready queue and we will allocate CPU to the process P1. At 1 second, when process P1 executes 1 seconds, and at 1 second we can see that there is a two process arrive in a ready queue, process P1 and P2. Then we will see which process have the minimum burst time. So we can see that P2 have minimum burst time, so we can allocate CPU to the process P2, and P2 execute process P2 executes 1 second, and at 2 second we will see that we can see that in this example process P1, P2, P3 arrived in a ready queue. After that we can, according to their algorithm, we can see we will see burst time, and we can see that at process P3 they have minimum burst time. So we can allocate CPU to the process P3, and when process P3 execute their process at 1 second, and we at 4 second at 4 second we can see that there is a 5 process arrived in a ready queue, and after that we will again we can search which process have minimum burst time. So then we can see that P3 have minimum burst time, so we can allocate process P3, and after the completion of P3 we can allocate the CPU to the process P6 because P6 have minimum burst time, and P6 process wants only 1 second for their execution. It means CPU to allocate to the process P6. After that P6 terminated, and rest of the process P5 they have on they wants only 1 second 1 second for they want 1 second of CPU. So we can allocate CPU to the P5. After that we can allocate CPU to the process P2, and at last we can allocate CPU to the P1. So in this example we can also calculate completion time. P1 their completion time at 19 millisecond, P2 2 millisecond. At 30 second P2 will execute it. At 6 second P3 will execute it. At 4 second P4 will completed their execution, and P5 at 9 second 9 millisecond P5 process will execute it. Turnaround time, we can calculate completion time minus arrival time, and waiting time we can calculate turnaround time minus waiting time. Every time we can add all sum of all waiting time divide by number of process. It means 4 milliseconds of average waiting time, and 7.16 millisecond is the average turnaround time. Priority scheduling. Priority is assigned for each process. Process with the highest priority listing number is assumed here, is executed first, and so on. Process with same priority are executed in FCFS manner. In this example, we can see that a process P1, P2, P3, P4, P5 along with their arrival time and burst time, and also with priority. And in this example, less in number, higher in priority. So first of all, we can see when process will arrive. So we can see that at 0 second process P1 arrived in a ready queue. So we can allocate CPU to the process P1 at 0 second, and process P1 wants CPU for a 7 seconds. When completion of the process P1, we can allocate to the process P3. P3 because P3 has less priority, and in this example we can say that we said that less in number, higher in priority. So P3 has 1 millisecond. It means we can allocate CPU to the process P3, and after the completion of process P3 we can allocate to the CPU to the process P2 because P2 has less priority among the process, and after the completion of the process P2 we can allocate to the process P5, then process P4. So completion time of the process P1 is 7, P2 is 13, P3 is 8, P4 is 23, and P5 is 21. And we can also calculate turnaround time by using this formula, completion time minus arrival time, and we can calculate also waiting time by using this formula, turnaround time minus birth time. The turnaround time of the process is 7, 12, 6, 20, 17, and waiting time of the process is 0, 7, 5, 18, and 9. Average time of the average time of the uh, average time is sum of the all waiting time divided by number of process is 7.8 millisecond, and average turnaround time is sum of all turnaround time divided by number of process. It means average waiting time is 7.8 millisecond and average turnaround time is 12.4 millisecond. And last algorithm of CPU scheduling is round robin. Round robin is similar to FCFS with preemption. Each process is provided a fixed time to execute. It is called quantum or slice. Once a process is executed for a given time period, it is preempted and other process executes for a given time period. Context switching is used to save a state of preempted process, and round robin decrease response time. So in this example, we can see that process P0, P1, P2, P3 along with their arrival time, burst time and quantum time. 3 millisecond is a quantum time. It means for a 3 second we can allocate CPU to CPU among the process. So first of all, we will make Gantt chart of this example. At 0 second, we can see that P not arrive in a ready queue, so we can allocate CPU to the process P naught, and P naught wants CPU for a 5 seconds. But in a round robin algorithm, we can allocate CPU only for a 3 seconds. After that, we can allocate process CPU to the process P1, because this algorithm will execute according to FCFS with time quantum. And after that, we can allocate process CPU to the process P2, then process P3, and when uh, P3 executes their process for a 3 second, we can allocate process P naught. After that, P naught wants only 2 seconds because 3 seconds already executed, and after completion of P naught, we can allocate CPU to the process P2. After that, we can allocate CPU to the process P3, and at last we can allocate process CPU to the process P2. So completion time of the process are 14 second of P naught, 6 millisecond of P1, 22 second of P2 and 20 millisecond of P3. Turnaround time we can calculate CT minus ET, it means a completion time minus arrival time, and we can calculate waiting time by using this formula, turnaround time minus burst time. It means average time is 8.5 millisecond and average turnaround time is 14 millisecond. These are the references of this algorithm. Thank you so much.